Basic operations with literals. There are 4 basic operations in arithmetic: addition, subtraction, multiplication and division. Similarly, we have all the 4 operations in algebra also. In algebra, all other operations are treated the same way as in arithmetic, but the operation multiplication is special in algebra. In algebra, if there is no sign in between 2 variables, this means these variables are multiplied. This means A into B can also be written as AB or BA. Sometimes this helps to a complicated algebraic statement look easier. For example, A into B plus 2 into B minus 3 into A can be written as AB plus 2B minus 3A. This looks simpler. Let us understand the properties of addition of literals in algebra. Like numbers, the addition of literals have the following properties. A plus B is equal to B plus A. A plus B plus C is equal to A plus B plus C. A plus 0 is equal to 0 plus A is equal to A. However, subtraction of literals does not have these properties. The only property that holds true for subtraction is A minus 0 is equal to A. Properties of multiplication. Like numbers, the multiplication of literals have the following properties. A into B is equal to B into A. A into B into C is equal to A into B into C. A into 1 is equal to 1 into A is equal to A. A into 0 is equal to 0 into A is equal to 0. A into B plus C is equal to A into B plus A into C. A into B minus C is equal to A into B minus A into C. However, for division of literals, we just have the following properties. A divided by A is equal to 1 and A divided by 1 is equal to A. Remember, 0 divided by A is equal to 0. The next we are going to learn how verbal statements are transformed into algebraic statements or expressions. Example 1. Find the sum of a number and 12. In this verbal statement, we see the word sum, which means addition. The next word that we see is a number, which we can consider as x. So, we can write the algebraic expression as x plus 12. Example 2. Find the difference of a number and 15. In this verbal statement, we see the word difference, which means subtraction. The next word that we see is a number, which we can consider as x. So we can write the algebraic expression as x minus 15. The vocabulary used to signify addition are added to, sum of, increased by, more than, greater than, plus, older than, heavier by, etc. Similarly, the vocabulary used to signify subtraction are minus, less than, subtracted from, difference of, decreased by, younger than, lighter than, smaller than, etc. There are a lot of ways of representing addition and subtraction. Some of the instances are 1. 7 more than a number is represented as x plus 7. 2. 14 less than a number is represented as x minus 14. 3. 3 decreased by a number is represented as x minus 3. Example 3. Find the product of a number and 8. In this verbal statement, we see the word product, which means multiplication. The next word that we see is a number, which we can consider as y. So, we can write the algebraic expression as 8y. Example 4. Find the quotient of a number and 10. In this verbal statement, we see the word quotient, which relates to division. The next word that we see is a number, which we can consider as y. So, we can write the algebraic expression as y divided by 10. The vocabulary used to signify multiplication are times, multiplied by, product of, doubled, tripled, of, half of, etc. The vocabulary used to signify division are divided by, quotient of, into equal parts, 1/2, 1/3, etc. The vocabulary used to signify equal to are total, adds to, equals, is the same as, is, will be, results, etc. Let us see some of the other examples where verbal statement is converted into algebraic expression. 1. 3 times a number, subtraction from 5. 5 minus 3x. 2. 7 added to the product of 2 and a number, 2x plus 7. 3. 1 less than the quotient of a number and 2. X divided by 2 minus 1. 4. 6 times the sum of thrice a number and 2. 6. Bracket 3y plus 2. Now we will see how two quantities are compared. Example. Shreya is 3 years older than Siddhant. In this statement, if we know Siddhant's age, then we can find out Shreya's age. Let Siddhant's age be x years. Then Shreya's age will be x plus 3, as Shreya is 3 years older than Siddhant. Equation and its solution. In our previous lesson, we have studied about algebra and how verbal statement is transformed into algebraic expression. How do we write the verbal statement, the sum of 5 and 3? We write it as 5 plus 3. This is a numerical expression. Now, let me say this verbal statement in a different way. The sum of a number and 5. Since this number is unknown, we express this unknown number by a variable x and thus write x plus 5. This is an algebraic expression as it consists of a variable. Now let us transform this verbal statement. The sum of a number and 12 equals to 15. This can be written as the sum of a number and 12 means x plus 12 equals to 12 means equals to 15. Now, this is no more called an algebraic expression. We call such statement as algebraic equation as there is an equal to sign here. An algebraic equation, or simply an equation, is a mathematical statement which consists of variables, constants, and an equality sign. In this lesson, we will study about equations in more details and solving an equation. Mohan went to market to shop few types of stationery. He bought 2 notebooks and a storybook costing rupees 120. The cost of notebook was not known, which we can consider as X. Mohan paid rupees 170 to the shopkeeper. Let us transform these verbal statements into an equation. We know that the cost of the notebook is rupees X and the cost of the storybook is rupees 120. The total cost of all the items is rupees 170, which Mohan paid to the shopkeeper. So, X plus 120 is equal to 170 is the required equation. An equation has 2 sides. The quantity on the left of equal to sign is usually called left-hand side, in short, LHS. And the quantity on the right of equal to sign is usually called right-hand side, in short, RHS. In this equation, the quantity X plus 120 is the LHS and the quantity 170 is the RHS. It is important that the value of these 2 quantities should always be equal. Then only we can say that the equation is true. Let us understand this with the help of a beam balance. Consider the same equation X plus 120 is equal to 170. We place the LHS of the equation on the left pan of the balance and the RHS on the right pan of the balance. Now, if we consider the value of X to be 10, then this value, as we can see here, does not satisfy the equation to be in balance. Let us put the value 20 in place of X. We still see that the equation is not balanced. If we put 60 in place of X, we see that the left side of the equation becomes greater and thus it does not balance the equation. If we put X equal to 50, we see that now the equation is balanced. Since the value 50 satisfies the equation to be in balance, therefore X is equal to 50 is the solution of the equation. The value of the variable in an equation which satisfies the equation is called the solution of the equation. Let us now see few examples to understand the topic better. Example 1. Is this an algebraic equation? 34 is equal to y plus 2. Yes, this is an algebraic equation as it contains a variable, a constant and the equal to sign. Example 2. Is this an algebraic equation? 6y minus 3 is greater than 45. No, this is not an algebraic equation. Though it consists of variables and constants, but does not contain any equal to sign. Example 3. Is this an algebraic equation? 24 divided by 4 is equal to 6. No, this is not an algebraic equation as this doesn't contain variable. Example 4 is y is equal to 10 a solution of the equation 2x is equal to 10? No, y is not a solution of the given equation because if we put y is equal to 10 in the equation, we get 2 times 10 equals 20. Thus, LHS is not equal to RHS. Example 5. Is x is equal to 7 a solution of the equation 3x minus 1 is equal to 20? Let us put the value of x in the given equation. 3 times 7 is 21. Minus 1 gives 20. So we get LHS equal to RHS. Thus, x is equal to 7 is a solution of the given equation.